So obviously we have a stock blank that doesn't have, it's just a square blank, and obviously doing it this way, you're gonna be, you know, pretty much using up all of that stock, and you might want to use that stock, for something else. So, of course, you would save it, but this is just one way to do it. With the locating pins diagonally to flip the part from top to bottom. And this is just another way you could do it. If you just want to machine the blanks and locate the blank, you can use a frame type fixture just to insert your blank, position it, and turn on your vacuum board. Then you can pop this frame up and you're ready to go. And then also, obviously, just a blank of the guitar body itself. Okay, so let's get these parts turned back on here so we can start talking about the control geometry. So basically on the left, we got two setups. We got the setup for the top and a setup for the bottom. So for the top setup, we're starting out with a facing operation. So basically for facing, if we go and look at this from a multiple port layout, the facing operation uses there's a contour perimeter curve around the guitar body. This is the exact shape of the guitar. We'll be using this for finishing, and also for side 2, we're going to be using this for your profiling to actually complete the machining and separate. If you're using a square blank, it'll release the guitar body from the blank. That's our last operation on side 2. Let's go ahead to look at some of the pocketing operations.
Can you turn on the toolpath?
Yeah.
So we can see the toolpath.
Might want to do that. So there's our facing. And let's go ahead and we got a number of pocketing operations that use flat areas at the bottom of the pockets as the control geometry. Let's turn that back on. And then some more pockets here, different levels of pockets. Another pocket here and here. And obviously the neck pocket there. Now roughing. Basically, you would use these two contours right here for the roughing operation. So it's just going to rough between these two areas right here. So the roughing the perimeter fillets, and also this contoured area here, and also around filleting around this edge.
So Don, there was a question about how did we create these boundaries?
Okay, so let's just look at the control boundaries for the top. Basically, what we have here is the way to create these is a number of different ways. Obviously, you're going to use your part geometry, and the Rhino has many different curve creation commands. You can create a silhouette around the part or a contour around the part to create a curve, and then that curve is either offset outward or offset inward to create a region between the two. So we're using a number of offset curves. Here's the perimeter curve, and then we're offsetting that outward on this side and on the inside as well. And there may be areas where you're going to have to tie it off to form a closed loop, because you do have to have a closed loop if you're going to contain your 3-axis operations. It has to be closed. So we tie it off on this end and just tie it off on that end.
So I guess the message to our listeners is that once you get the model of your 3D model of your guitar body, there is some additional construction you'll have to go through and create these boundaries to contain your machining, so you can do that in a very optimized manner, as Don is showing here.
Mm-hmm. Yeah, so you don't want to machine everything. If you don't have to machine everything, you don't want to remachine what you've already machined. So the control geometry is going to help guide the cutter to machine only the areas that are pertinent to that particular operation. For finishing, basically, we're using the same control boundaries here, where we're finishing just the fillet and the fillet on this side, and then the this contour area here. So we got basically facing, a number of pocketing, a couple of roughing operations, and a couple of and a parallel finishing operation. If you recall, I talked about the stock blanks. This is sitting in a square blank that's already been machined. It's been squared up. It's got locating holes in the corners, and basically you only use two of the locating pins. You set up the one side. You can have a work zero. That work zero can be at the top, upper and outer quadrant of the stock, or at the bottom. Either way, it'll work. And the thing is about these square diagonal pins is that you set this up for the top side and set your machine zero. Then when you're done with that side, all you got to do is flip it over this way and machine the bottom. So let's go ahead and just flip that over. You'll see what I'm talking about. So you just flip that over, and then for the bottom, you'll use the same. You don't even have to set the machine zero again. It's the same location. Okay, so let's.
Hey, Don, before you jump into that, there was a question on those two locked operations that you have. It might be a good segue into describing the functionality of locking operations.
Yeah. Okay, that's a good point. Basically, you see the little lock on the operation. These are alternate methods of finishing that I used. Let's go ahead and turn this off, unsuppress it. And there is one of the finishing operations I used for the top. It is a parallel finishing operation, and then also a second finishing. Let's unsuppress that. So basically, these two finishings go in opposite directions along the X, and then also along the Y at 90 degrees to get maximum coverage for your surface finish.
The idea of these locked operations is that, like Don mentioned, these could be alternative ways of machining that you want to keep around for later maybe use, or maybe even looking at it and maybe using it later. But maybe you don't want to post these out. So if you select post all from the machining job, these locked operations will not be posted out, or neither would they be simulated. So they're basically there as archived operations that you can open up later on and do whatever you think you want to do with these operations. Pretty nice functionality based on some of your user input. So.
Yep, and it's going to come in handy right now, because since I messed up my first finishing, I'm going to lock that. I'm going to lock that and leave these other two turned on. I'm not going to generate them right now, but okay. So that is set up top. Now, because you're using a square blank with diagonal locator pins, and the guitar body is in the center of the block, basically all you need to do is flip the part over, and we're going to go ahead and do that. Flip it over. And let's go ahead and turn this blank off.
When Don says flip the part over, he's really not physically flipping it. He's not doing a transformation of the part. All he's doing is rotating the view. And in our CAM system, we can do a setup, which basically reorients the tool axis as if you physically flip the part and machined from the other direction. So it's pretty handy. And this is available only in our Pro and Pro configurations, and also the 3+2 add-on module. If you wanted to add that, then you would be able to get the additional setups and the ability to actually do flip machining. We actually did a webinar on that, I believe, 2 months ago. Yep. And if you're interested, you can view that on our YouTube channel.
Yeah,
Thanks,
when I was talking about flipping, I was talking about the physical flipping of the stock blank on the table using the locator pins.
Yeah, that is on the machine. I'm talking here on the CAD system or in
Yep.
Rhino. You're not physically flipping it.
Exactly.
You're just machining it from the other side, but on your machine, you're going to physically flip your stock.
Mm-hmm. And that's a good feature of the Pro configuration. If you only had the standard, then you would have to have separate CAD files for the top and for the bottom, and that can introduce a lot of inaccuracies, of using two different part files, etc. So for the bottom, we're going to, again, do a facing operation for the bottom. And here is our roughing. We really only need to rough on this contoured area over here. So we got a roughing operation to get rid of some of that material over there. And then in this, on the bottom part, we're going to use a horizontal finishing operation. Now, what we're doing here in the horizontal finishing is we're containing, we use the perimeter curve. So the entire guitar body is open for machining. But what we're doing is we're limiting the location of the operation in the Z-axis. So we're saying we're going to go up, to the very edge and then stop, maybe 10, probably more than 10, probably 10 to 15 thousandths below the top face, so that only the contoured areas below the face inside of the perimeter will be machined. So you see, just by using the outer perimeter and some Z containment, you can get your toolpath coverage in the exact location that you need it to be. So there's our horizontal finishing for the contoured areas. And then our last operation will free the stock from the blank, and that is a 2.5 axis profiling operation. If anybody has any questions about the guitar body blank machining, please type them in the questions box and we'll get right to them. I'm going to move over to the guitar body neck. And
hang on, Don, I think you should run the simulation there to show how that looks, before you do that. And also, there was a question about Z containment.
Let's go ahead and
look at do Z containment.
Okay, well, let's look at the horizontal finishing operation. So what I was referring to basically is that when you got one drive region and it's around the perimeter of the part. So everything inside this perimeter is open to be machined. But we don't want to machine this top face because we already machined that already, or it might have been already pre-machined. So what you can do is go into the cut levels tab and you can set constraints on your cut levels. So you see here I've got the top T checkbox checked. So we're constraining the very top of the toolpath to -1,000. Actually, just 1,000ths below the top face. That means that obviously it's not going to cut the top face. It's going to cut everything 1,000ths below that out to the perimeter of the guitar body. And then we have a bottom B set, which just makes sure that the operation doesn't dip below our lowest fillet here. Okay, I hope that answers your question. And again, I was talking about the profiling. This operation will, the last operation that you do will free the part from the stock blank.
Yeah, can you run the simulation now?
Yep. Actually, I have it simulated, but we can go ahead and run it. Also, let's turn the toolpaths off. Let's go to the top. And let's go ahead and simulate. Let's go just one at a time since they go pretty fast. So there's the facing, the pocketing, one of the pockets, and here is the second pocket to bring this pocket down deeper, and obviously our pocket there, and another pocket there as well. And for the neck, another pocket. So there's our 2.5 axis operations for the top side. And then we have, this is our roughing operation. Again, it's not adhering to my control boundary. I'm not sure why. Let's pause that. Stop that. Go back into that operation. Let's remove that. Select that again. Generate. There we go. So we got roughing just around the fillets, a little bit of roughing, and over here in the contoured area. Let's go ahead and simulate that. So there's our roughing. So let's go ahead and do our horizontal finishing. And looks like I need to go ahead and reselect that as well. Remove that. We'll go ahead and reselect that. Generate it.
So what Don's doing is basically containing the horizontal finishing or Z-level finishing between those two curves, so he's not going on the outside of the part.
Mm-hmm.
And it does take a while.
So there's our horizontal finishing, and I had an option turned on to follow the containment area. I can turn that off so it'll stop at the bottom. I don't want to regenerate it again, so since we got other parts we want to look at. So let's go ahead and take a look at the finishing at least in there. Let's go ahead and play that. Okay, so I got a couple of additional finishings here.
So
just to
Don, there was a question. Are you machining it so it goes all the way down to the bottom of the stock, or are you stopping in the middle?
Now, for the parallel finishing, let's go ahead, the horizontal finishing. Let's go ahead and look at that. We do have a bottom B set, okay? But because of the containment of this outer perimeter, the tool cannot go any further than the bottom fillet tangent, okay? The tool is not going to go out even further than that, and it's not going to go down any further. Let's look at the tool path again in that area. Again, it's only going down just slightly below the tangent area. It would be good if I
Yes.
regenerated that, but I'm going to leave that for now.
So I think what Don has done.
There's a good view of it right there.
Yeah, so what Don's done here is he's taken that curve and offset it out by tool radius, and so the tool's got just enough space to go to the edge of that body. And then he's also put a Z containment, so it stops at that Z level. And then when he flips it over, he's going to come back in with the profiling operation and clean the outsides. That works very well.
Okay, let's take a look at